In Algebra 2, today we're going to talk about trig ratios and special angles. Here I have a equilateral triangle, okay? Therefore, each of these angles is going to be 60 degrees, okay? 60 degrees. Now we're going to create a special triangle here. If I were to draw a line going straight down, it cuts us into two equal triangles. So I'm going to create a new triangle here with just the right half. Okay, and let's use the smallest even number we can find. If we know it's 2, 2, and 2, because again it's equilateral, meaning all the sides are the same length. We have here 2 is our hypotenuse. This remains 60 degrees, and that's a right angle. So if this is 60, that makes this one 30. Okay. So now if this is 2, this whole length is 2, and we have cut this now in half. It's split into 1 and 1. So notice here, the angle opposite the 30 degrees is half the hypotenuse. So 2, 1. Now in order to find this last side, let's call it B. Okay, it looks like a 6. Let's call it A. So we have A squared plus B squared equals hypotenuse, or C squared. So we have A squared plus 1 is equal to 4. And then we get the A squared by itself. Minus 1 is 3. And then lastly, we do a square root. A is equal to root 3. So here's what you have to remember for this assignment. When you're dealing with a 30, 60, 90 triangle, the hypotenuse will be 2. The side opposite 30 degrees will be 1. The side opposite 60 will be root 3. And for this assignment, this will always work. Okay? The hypotenuse will always be 2. Opposite 30 would be 1. Opposite 60 degrees would be root 3. Okay? Now this is a ratio, and later on we'll apply different numbers there. But for this assignment, it's 2, 1, root 3. Okay? Now that's the 30, 60, 90 triangle. The next one we have, way down here, we have a square. Okay? If I say this is a square, so all these side lengths are going to be the same amount. If I draw a diagonal here, actually I'll do it this way. If I draw a diagonal, and I were to get rid of, oh, I don't want to get rid of all that. If I were to get rid of this half on this side, that would leave me with a right triangle in which these, what were right triangles, right angles were cut in half. So now this becomes 45 and 45. And since this is isosceles triangle, because there's two that are the same, we know these side lengths have to be the same. So 1 and 1. The question is what's the length of the hypotenuse? So we have 1 squared plus 1 squared is equal to our hypotenuse squared. So 1 plus 1 is c squared. So 2 is equal to c squared, then we root it. So c is equal to the square root of 2. Okay? So here goes our ratio. When we're dealing with a 45 degree, 90 degree triangle, the two legs that made up the right angle would be they would be the same exact term, or same exact number. So 1 and 1, our hypotenuse would be root 2. Okay? Again, it's a ratio. If this were a 4, that would make this a 4, making that 4 root 2. 4, 4, 4 root 2. But in this case, let's keep it basic. 1, 1, 1 root 2, because this is what you're going to use on the problems that are going to be assigned. So let's take a look at how we use this. So, find each trig ratio. Tangent of 135 degrees. We have to find the ratio of 135 degrees, and let's say we have to also simplify the radicals. So what that means is we don't want any square roots in the denominator for our final answer. So here, tangent of 35, what you want to do first is graph that angle. If you 135, we start always on the positive x-axis. This would get us back to 90, and then 135 is going to be in the second quadrant. And if we went over 135 degrees, this being my terminal angle, it's going to take 45 more degrees in order to get to 180. So I know this underneath right here is going to be 45 degrees. But again, I can create a right triangle, which means that's 45 degrees. Okay? Now again, since it's a 45-degree triangle, we know it's going to be 1, 1, root 2. But since we're dealing with an xy coordinate plane, since this is going back, this is going to be a negative. Okay? So the tangent here from our terminal angle, okay, tangent is going to be opposite 1 over adjacent, negative 1. So our final answer is negative 1 for the tangent of 135 degrees. Again, graph your angle, put your terminal side, and create the triangle. We have to figure out how many degrees are underneath that angle right there, or underneath the terminal side. Now the next one is secant of 240. That's not a straight line at all. Secant of 240, neither is that. So, starting on this side, 90, 180, secant 240, or sorry, 240 degrees is going to be in the third quadrant. If halfway across those 180, that means 60 degrees more in order to get to 240. So now here we have a 30, 60, 90 triangle, in which the hypotenuse, again, when we did that, it's 2, 1, root 3. The hypotenuse is 2, side opposite 30 is 1, side opposite 60 is root 3. So we have here 2, side opposite 30 is 1, side opposite 60 is root 3. Since it's going to the left, we know it's negative. Since it's going down, we know it's negative. And lastly, it says, find the secant of 240. Secant is hypotenuse over adjacent. So hypotenuse over adjacent. And 2 divided by negative 1 gives us a negative 2. So that is our answer for the secant of 240 is negative 2. Again, draw your angle. We went over 180 and then 60 more to find our terminal angle. We set up our ratio, and there we have it. Alright, so these are the type of problems you're going to have to do for the homework. Good luck.